Hello, welcome back to my bench. Today we're going to do a little preventive maintenance. I've got this Eico 378 audio generator that I really like. This thing, it's the output of it is just really clean. I can get this down on a distortion analyzer down less than 0.1%, and I use it primarily over on my burn-in bench when I'm doing things like mic processors and audio amplifiers and things like that, to just run them on the burn-in bench for several hours to a day and check the output and see if it changes in distortion any. And this thing is great for that because it's just so clean. I've noticed recently that it kind of hums a little bit when it's running, and I want to see if we can fix that or if there's anything wrong with it. Basically, it's a very simple audio generator. It's got your frequency down here between ×1 and ×1000. This is your cycle. So right now it's on 10 × 70, which is 700. This is your fine tuning for cycles per second down to ones. Output range goes between -50 and +20. Or 0.003 volts up to 10 volts of output. The 10 and 20 are high Z, so you don't use those, and normally you just leave it on the 0 level because no matter what you're going into, you want to reference it to something, and referencing to 0 is pretty good. This is your output, fine tuning output for to get your range where you want it. Theoretically, if this is up all the way and that's on 0, you've got 0 level output. I don't really care about that too much because I just take this thing and hook it up to the input of a device, bring the device's own meter up to 0, which I've already verified on the bench, and I know where it's supposed to be, so I just crank this up to where it needs to be, and then let it run for a long time. You got an internal and external loads. This is a 600 ohm internal load, which most of the time and most of what I work on, that's where you leave it. You can also put it on an external load. If the external load is 600 ohms, you can leave it there too. And depending on what you need. And it's got audio outputs down here, an on-off light, and a meter. Unfortunately, the meter's dead. I wish I could find a meter for this. I have not been able to find one. They're kind of rare. But like I said, I don't really use it that much. The meter doesn't matter to me because I know what I should be feeding the device and showing up what it is. And if I have to, I can put a meter across it and measure the voltage. So that's what's on the front. On the back is pretty much nothing. This one had been messed with a bit. It had a output here for headphones. The cord needs to have one of those strain reliefs on it because it's just kind of sitting there against the sharp edges, not good. And there's an extra hole over here. I don't know what that was for, but it hadn't bothered me. I think I took this portion out. I think it had a transformer coupled output here, and I think I took that out. But anyway, what we need to do is first take this thing apart and take a look at it and see what is inside. So let's give it a shot. A couple of screws in the back, that's about it. That's what holds this thing together. Most of the Eicos were like this. They're just a couple of screws holding the case on. This one feels like it's been a little bit bent because the screws don't come out very easily. This one's in pretty good shape. I like, it's clean, it's neat, and except for that meter, everything on it functions. Wow. Okay. All right. So, the bottom's got a tube chart. Nice. 6X4, 6CL6, and 6AU6. It is transformer coupled, which is good because you don't want things backing up on you through the line. All right, well, let's take a look at the top first. Yeah, this is in pretty nice shape. Here's the transformer, the meter. I don't know what this is. Oh, that's to drive the bulb. It's got a little neon bulb. Got a couple of tubes. Here is I think that's the balance for null. I think. Don't quote me on that. It's got a 6X4 and the other tubes. This one looks good. 6CL6. Big old capacitor. And 6AU6A. And a light bulb. This is a relaxation oscillator, and there's a light bulb for that, and it is specific 3-watt, 120-volt light bulb. You can't change it with anything else. It has to be that. All right, let's take a look at the bottom. Oh, nice and clean. Very well built. Somebody's added a fuse. Here's that audio output connector somebody had added in here, which I cut out, took away. Here's your resistors for setting your values and your capacitors. They're all high quality, good stuff. Here's your capacitor down here, your main filter cap. We got, what's this one? 20 microfarads at 350 volts. And this one is 350. No. This one's broken off. Okay, this was a kit, I guess. Anyway, so this one is what? 125622 16F 350 to 400 volts. I don't know. I'm going to have to look and see if I have a manual for this. Hang on a sec. Okay, so, yes I do. I have a manual, and here it is. This is the schematic for it. And what have we got here? This capacitor, which came unglued, is coming off of pin 7 of the 12AU7. So, or what is this thing? 12AU7? 6AU6. I wasn't very far off. Okay, so it's coming off of pin 7 of the 6AU6. Whoops, which would be Pin 7 at 686, the capacitor 16 at 350. Alright, whoops, right here. So, how's that read? That's a weird one. Okay, so it says 16, and I guess there's a U there. We're probably going to have to change that. We can check it though. Let's find out. Get the little tester here. Alright. She's set. Not really worried about this, but zero it out. You know what though? I'm going to short that out a few times. And you guys too. Alright. This thing, I don't know, it might go poof if you hit it too hard with electric. I'm sure it would. So, what do we got here? Wow. Come on. Hard to hold all this junk. Point. About 0.4. That's fine. That's amazing. Let's see. What's this guy? He is also 0.4. 0.4. And what about you? Where do you go? Okay, you go over to here and to here. That's 2.2. That probably needs to be replaced. 2.2 might be a little high. Let me go get one. And I'll get a 16 at 350 also. Well, I don't have any 16s. I have 22s. So, I don't think... Where does this go here? Bring the manual back up. This goes between the grid, suppressor grid, and the grid, and the output. Well, I'm not sure that would make a lot of difference. I think we can get away, although we really don't need to. That thing is fine. Let's give it a quick measure just for fun here. Negative, positive. 16.76, great ESR, no problems. I'm leaving that alone. So, however, we probably should actually solder it back in where it goes, though. I've not actually worked on this before. I took this thing out back here, but I didn't actually replace anything. So, these things came two ways. They came as a kit or as a pre-built by the company. I believe, from the looks of the soldering in here, this one was indeed a kit. It's just not clean enough to be company made. Alright, so let's see. This one, we're just going to cut it out. So, we're going to replace this guy right here. This guy's soldered back in. We'll cut you out just because you're 22. Probably doesn't mean much, but we'll find out. So, Okay. Come on. Putting the little don't short me out thing back on here. Good mechanical connections. Yeah, well, in this case, it's only care about the good mechanical connection because I want it to stay holding itself up. Good mechanical connections are important. They sure make it a lot harder to fix, though, when you need to repair the thing, because they're well, you got to unwrap them. Yeah. Want to make sure I did that right. Oh, glasses. Come on. Giant day blob of solder on this mess here. Okay. Can't work with my left hand worth a hoot. Yeah, there's stuff on here that's soldered, but very strangely just sort of blobbed on. Unfortunately, there's not enough on that for me to finagle with it, so it's going to have to just be blobbed back on. But at least I'll make the blob cover the whole thing. How's that? Yeah. Crap. And that is not good there. That was actually trying to short to ground. Let's at least get you stuck through the hole here. There we go. We'll move that out of the way of that tube once we get it all soldered back on. All right. That thing actually solder. Yep, it did. All right, get you out of the way. What is that? 20 watts, 5K. All right, that thing tested good. This thing's been replaced. This is good. And that's good. Phew. Well, tell you what, let's turn it over, turn it on. The humming that I heard may have just been from the transformer having poor, being a little loose, where all those plates go together and lined up in here. Sometimes they get loose and they'll vibrate a little bit. It's not the end of the world type of deal. Does this have? No, it doesn't. It's a transformer. Why would it? Okay. And turn you on. All right. Put it into the... You off? Yep, you're off. All right. Turn it, put it on the light bulb. Aha. No light bulb. No power. Oh, did I turn you off? Okay. Here we go. No power, no light bulb. Good idea. I got a 60-watt light bulb in here. Everything seems to be fine. Yep, okay. Take it off the light bulb, bypass it. Let's pull up the scope. Scope. There's the scope. Ground. And I just scared the heck out of the scope. Interesting. Wow. All right. There it is down there. If you in this program, if you change your input, you have to go reconnect it again in OBS. So let's see, let's take this down to 1 volt and 500 millivolts. There we go. All right, well, it's wobbling around a little bit, but it's, I don't know what's making it do that. See, when I take the, when I put on external load, that goes up because there's no load to it. What does it say we're reading here? Let's go to measure window, and we'll go to RMS voltage, about 686 millivolts. Crank this up, it's about 1 volt. That's what it's supposed to put out. And our frequency is about 684 kilohertz. So 694, there you go, 700. It's off a little in frequency, but I don't really care. Yeah, that looks pretty good. Let's change my output, see how it looks as we go down. Now this scope isn't going to be fantastic. Got some noise in it. But that looks pretty good to me. Well, it looks like it's working okay. And I don't hear any hum anymore. At all. You notice, if you look at this, let's get you out of the way. We'll keep you here just so you can see it. If you notice this light bulb back here, it's not lit. It's not supposed to light. If we look at the manual, get rid of the scope for now. If we look at the manual, that light bulb is right here. And it's never going to draw enough current to light up. But it is part of the oscillator control circuit. If you can see right here, it's called a relaxation oscillator. And if we turn this over here, it'll change how much goes through the light bulb. I see where it's at, so we can, let's see. Let's get rid of you and turn on you. And if I turn this, you can see it. That's the relaxation of that light bulb. It's working fine. It's not humming anymore. Light bulb's not lit. All right, so let's take this at 0 and see if we can going to get it into the distortion analyzer. If I can get my cables out of here. Okay. Wow. A lot easier said than done. Alright. Alright, we're on what? Let's put it on 700 or thereabouts, because that's about where I put this thing. Adjust the level. Let's see, what does my voltmeter say? Plus 20. Well, let's see. That says, what am I looking at? 0 percentage dB. 0 dB. Okay. And crank this down. Where am I at? Okay, so where am I at? Oh, gee whiz. 700. Hold on. Well, so far so good. No. Take it down. Here, if I can get this camera, I'll show you. Get rid of the scope. Go back to this guy here. Here. Alright. So basically, I have to adjust the frequency here. The best I can. Then I hit the null the best I can. And the frequency again. Take our step up. We're on 0.3%. If you can see over there. Gets pretty touchy about now. You're starting to pick up noise in the air. Just noise around you. Okay, so we're at 0.3%, 0.1%. So we're looking at 0.04. That is pretty darn good. I can live with that. Don't need to know any more about it. Anyhow, basically that's it. Looks inside one of these things, change out a cap. Can't hear that humming anymore. Maybe it was this thing. I don't know. I don't have a leakage tester here with high voltage leakage tester, so, and besides I got those guys, we're just going to leave it at that. Hey, there you go. Just a little preventive maintenance on an Eico 378 audio generator. Thanks, guys. Till next time.